Alright, so welcome to lesson 1 of polynomials, where we will classify, add, subtract, and multiply polynomials. So all of the things that we can do with real numbers, so classify as rational, irrational, integers, etc. And then add, subtract, and multiply numbers. We're going to do those same things with polynomials. We will get to division, but not in this video. So a polynomial that's written in standard form looks like this. All right, which is really just a fancy way of saying you're going to have coefficients. So a sub n just stands for a coefficient, a sub n minus 1, coefficient, etc. And then you have x's raised to exponents. All right, moving forward in this unit, we're going to refer to exponents and powers as degrees, not like the degrees that you would use to measure an angle. A degree is just another word for an exponent or a power. And so when we have a polynomial that's written in standard form, which we will need to write every polynomial in standard form, we have our highest exponents or highest degree in the front, and then they get smaller. So let's say this was x to the 5th, this would be x to the 4th, 3rd, 2nd, and so on. If you're missing one, that's fine. You just keep going in decreasing order. All right, we're going to revisit this table in a minute once we do an example, but it is there for reference. All right, so we're going to jump down to number 1, where it says simplify, write the polynomial in standard form, then classify. So in this first example, we have one polynomial, and then we're subtracting another polynomial. So this is really just combining like terms. So we can add and subtract terms that look exactly the same, so they're raised to the same degree or exponent. So this first term right here, 2x squared, I'm going to look for the like term, which is x squared over here. So I have 2x squared minus 1x squared, so that just leaves me with x squared. And then my next term is positive 7x, and I'm looking for my like term, which is negative 10x. So I have 7x minus negative 10 is positive 17x. And then my last terms, or my constant terms, I have negative 1 minus negative 1, which equals 0. So I don't need to put plus 0. I could, but that would not be in simplest form. All right, so now that I have simplified, I've made sure it's written in standard form because I have my x squared before my x. So this would technically be x to the first. Again, that's not really simplest form, so we don't need to write that. So x squared plus 17x is fine. Now we're going to classify the polynomial. So when we classify polynomials, we give it a first name and a last name. All right, so the first name comes from what's the highest degree. So this degree column right here refers to the highest exponent or the largest exponent. So in this case, it would be 2. So if the highest degree is 2, the name we give that type of polynomial is a quadratic. So this is a quadratic. And then we're going to classify also by number of terms. So this polynomial right here has 2 terms, so I go to the 2, and that's called a binomial. So you might think about the prefix bi as like a bicycle has 2 wheels, a biped has 2 feet, so that bi prefix just means 2. Alright, so 2 terms. Alright, so that's it. What I'd like you to do now is pause the video, and I want you to give number 2 a try, work it out, and then unpause the video to see if you got it correct. So go ahead, pause it now. Alright, so looking at this example, alright, we should get 10x, I'm sorry, we're not multiplying, my bad, 7x squared, because 2x squared plus 5x squared. Then we have negative x plus 3x, so plus 2x, and then minus 4. And that is also quadratic, but it's a quadratic trinomial. All right, so there's 3 terms there, so the last name that we would give that polynomial is a trinomial. All right, the word polynomial really refers to all of these, but we can get more specific when we have 1, 2, or 3 terms. Anything that's 4 or more terms we don't have a specific name for, we just call it a polynomial. All right, so moving on to number 3, we have multiplication. All right, now this looks pretty similar to things we've seen in the past. We have 7x out front, and we know that if that were just a 7, we would distribute it to x squared and 4. We're going to do the same thing with the 7x. So we're going to multiply 7x times x squared. That gives 7x to the 3rd power using our exponent laws. and then 7x times 4 is positive 28x. All right, so again, we're going to classify that. The highest exponent I see is 3. So I'm going to go up to my table. If the degree is 3, that's cubic. And that makes sense because if we were going to read that, it would be 7x cubed. So cubic. And then it has 2 terms, so again, that's a binomial. All right, again, I want you to pause the video here, try number 4, and then check back to see if you got it. All right, so for number 4, now we are multiplying. 4 times 2 gives us 8. X times x cubed is x to the 4th, minus 28x to the 3rd, and then plus 4x squared. All right, so that's the polynomial we should get. And I see that the highest term here, or I'm sorry, the highest exponent is 4. So I go up to my table, 4 is quartic. So this is a quartic trinomial. There's 3 terms there. All right, so now in number 5, we have, again, multiplication. So we have x plus 6 times x plus 3. Now this looks a little bit different from number 3 because instead of having one term, so 7x, multiplied by a group or a binomial, we actually have a binomial times another binomial. So I'm going to show you a couple of different ways that we can think about. The first way is using the distributive property. All right, so if this were just a 6, so let's say this was just 6 times x plus 3, then we would just distribute the 6 to the x and the 3. Well, instead of just having a 6, we also have to distribute an x. So here's what that will look like. I'm going to distribute the x first. So I know that x needs to be multiplied by this whole second group. So I'm going to write that as x times x plus 6 plus, and now I'm going to distribute the positive 6 to the whole second set of parentheses, so that binomial x plus 3. So 6 times x plus 3, sorry for the typo there. And now I have 2 sets of distributing to do. So I know x times x is x squared. I know that x, so I'm right here, so x times x is x squared. I know that x times 6 is just plus 6x. And now I'm moving, I'm so sorry guys, this should have been a 3, my bad, which would make that 3x. So let me just go through that one more time because that was probably confusing. So I'm distributing x and then plus 6, which is from this first binomial right here. I'm distributing that to x plus 3, so that was just my bad with a typo. X plus 3, x plus 3. So x times x is x squared, x times 3 is 3x, so now we're on to the second set. 6 times x is 6x, and 6 times 3 is 18. All right, now we're not finished now, or quite yet, because I see these 2 middle terms are like terms, so I need to combine them. So I have x squared plus 9x plus 18. Now all of my like terms are simplified and combined. It's in standard form. I can go ahead and classify this. So I see that the largest exponent is 2. So that means that it's quadratic, and there's 3 terms, so that makes it a trinomial. So quadratic trinomial. All right. I am going to switch something around real quick, so bear with me. Alright, let's see if this works. Nope, hold on. Oh, yikes. Alright, you know what we're going to do? We're going to skip down to number 7 because I already have that one set up, and then you'll do 6 and 8. Alright, so again, we're going to flip over the back, we're going to skip 6, we'll go back to it. Alright, so the first method I showed you for number 5 was the distributive property, just a little bit different from what we've seen before. I'm going to show you another method. It's called the box method that we'll do for number 7. Alright, so what I've done here is I've set up, and I did this ahead of time because it'll take quite a while for me to make that table, but you're going to just draw a box on your paper. So you've got a box and you're going to split it into 4 pieces. So draw a column, or draw a line down to make 2 columns, and a row to make I'm sorry, a horizontal line to make 2 rows. All right, and I'm going to treat this as the length of this rectangle, so that's going to be across my top, so 3x plus 5, and I'm going to treat this piece as my width. So I've got my length and my width. And I want to find the area of this rectangle, which is really just length times width, so multiplication. And I'm going to use these 4 small pieces of that big rectangle to do that. So this small box up here, all right, this first rectangle, I have 3x times 4x. That's going to be 12x squared. And then if I move over here, I have 4x times positive 5, so that's going to be positive 20x. And then if I move down here, I have negative 1 times 3x, so that's negative 3x. And then my final box over here is negative 1 times positive 5, that's going to be negative 5. So I have the same 4 pieces, obviously the numbers are different, but I have the same 4 pieces that I had up here. It's just a different strategy, different approach, different visual. So I notice that this box right here and this box right here have those like terms. All right, so they're both x's, so up here they were in the middle. All right, right now down here they are in this diagonal right here. So I do need to simplify those. All right, so I have my first term is going to be 12x squared, remembering I want this in standard form, plus, and now I have negative 3x and positive 20x, or positive 20x and negative 3x. Either way you slice it, that's 17x, positive 17x, and then my constant term is minus 5. All right, and now I have my standard form polynomial. And this is, again, a quadratic trinomial. This is going to be, I'm going to put a star next to this. This is going to be, or 5 stars, this is going to be the most most common type of polynomial that we'll see this unit. We're actually going to spend a whole unit on quadratics, which is our next unit. So you will see these quite a lot, but it is important to know all of the names. Alright, so what I'm going to have you do now is I'm going to have you pause for a little while. I want you to do number 6 and number 8, and I want you to try this strategy, so the distributive property that we did first, and the box method that we did second. So it doesn't have to be, you know, distributive here, box here, you can mix and match, but I do want you to get comfortable with both methods. So go ahead and pause. Alright, so in number 6 we should have gotten 2x squared plus 7x plus 3 after you simplified. Alright, and again that's a quadratic trinomial. And then in number 8, I might have to show my work for this one, we should get 28x squared plus 21x minus 24x. It's okay if you had those in a different order. Minus 18. And then when we combine those, we've got 28x squared minus 3x minus 18. All right, and again, that is a quadratic trinomial. Not much variation there. All right, so if you did not get either of those, please pause again, go back, fix your mistakes, and make sure you can arrive at these 2 answers. But I'm going to move on to number 9. All right, so looking at number 9, that blue? Okay. So I see that, or we see that we have 2x minus 3 squared. Now it's going to be very tempting, but we're not going to do it. It's very tempting to want to just square this and this. But I want to think about what I know about squaring. Well, squaring means something times itself. And since this whole binomial is in parentheses, that means that this whole binomial is the base of this exponent 2 right here. So that means that I really have 2x minus 3 times itself. So I'm going to rewrite that. I thought I had, there we go. Alright, so 2x minus 3 squared means 2x minus 3 times 2x minus 3. So if I distribute, or if I write it like this, now I can see that I can actually do distribution, or I can do the box method. Alright, so since we've already done 2 examples, I'm going to again have you pause, work this one out on your own, and then check back to see if you got it right. Alright, so welcome back. We should get 4x squared minus 12x plus 9. Alright, and then again, quadratic trinomial. I promise all the polynomials we see will not necessarily be quadratic trinomials, but there'll be a lot of them. Alright, so again, if you didn't get that one, pause again, go back, fix. Make sure you're showing your work. Another good strategy is to, if you're getting stuck, use the box method and use the I should put distributive property here. And you guys should write that down, distributive property and box method. It's good to do it both ways because that way you can check yourself. Alright, we're going to wrap this up. So number 10 here is a trinomial. So this first term here, or I'm sorry, this first polynomial has 3 terms. And this second one has 2 terms. So we are going to use the box method here. You are welcome to use distributive property moving forward, but since this is our first one, I want to make sure that we're organized, and the box method is a really good way to do that. Alright, so I've already laid out my x squared, my plus 3x, and my plus 4 across the top, so go ahead and do that. And then I've got my 2x plus 1 along the width here. So I'll give you a second to set that up. Alright, so I'm going to go ahead and do the same thing I did up here. Alright, I'm just going to multiply these side lengths. So I have x squared times 2x, that's 2x to the third. Alright, then going across my top row, I have 2x times positive 3x is 6x squared. And then my last box in the top row, 2x times 4 is 8x, and I should really be putting, and you should be putting these two the signs so we know if they're positive or negative. Alright, and then moving to the bottom row, which is actually super nice, we're just multiplying by positive 1. So every single term in these boxes down here is going to be the same as these up here because we're just multiplying by 1. So this will stay x squared plus x squared. Got to get better about that. This will be plus 3x, and this will be plus 4. Now, similar to before how we had these like terms across the diagonals, we have that here too. We just have some more. So we've got, I'll use green here, so we have these two terms, which are both x squared, and then I'll use orange or something here. We've got our x terms along this diagonal. So we've got 2 sets that we have to combine here. Alright, so bring this down. Hold on. Alright, so we've got 2x cubed. Alright, so that term right there has no like terms. It's going to stay what it is. And then I have 6x squared, and if you really want to see the 1, 6x squared plus 1x squared is 7x squared. Then we have 3x and 8x is 11x, all positive, and then our constant is 4. Alright, and as you can see, this is not a quadratic trinomial, this is a cubic polynomial. So again, anything that has more than 4 terms, 4, 5, 6, 7, etc., is just called a polynomial. You might remember from past classes that poly means many, so like a polygon has many sides. Alright, last thing. Alright, so it says the shapes in the figure below are squares, so that tells us that this side length right here is x plus 4, and this side length right here is x minus 1. Alright, so every side is equal to each other. Find the area of the shaded region. Alright, so area of a square is just length times width, or side times side. So if we want to find just the area of the shaded region, that's going to be the area of the large square. So the square that has x plus 4 as its side length minus the area of the small square, which is this little white guy right here. So, oops, I guess I didn't get that set up. Alright, so the area of the large square is going to be x plus 4 times x plus 4. Yes, you could write that as x plus 4 squared, but you're going to want to expand it anyway so that we can actually see what we're multiplying. So that is fine, minus, and then x minus 1 times x minus 1. So again, area of a square is just length times width, or side times side. Alright, I'm going to leave you guys there. Go ahead and finish that one up, so you'll either distribute or box method for this, and distribute or box method for this. And then you're going to have some like terms to combine. So this problem really combines multiplying and adding and subtracting all in one. And then when you get your final answer, go ahead and classify it as well. All right, so go ahead and finish that up. I'm going to go, and then you're going to fill out one thing I learned is and a question I still have is. So moving forward, when you come into class, you'll be able to share these out and get some clarification. All right, that's all.